This video is on factoring difference of squares. And what I mean by difference of squares is perfect squares. So it's a special case of factoring. And you always have to ask yourself that question, can I factor out a GCF? If that's the case, then you still do what we've been doing so far, but this is a special case in the fact that this is a binomial that you factor. Now, because it's factoring the difference of squares, it needs to be subtraction. If it was plus, you would not be able to do this type of problem. So it needs to be subtraction. Also, you do not have a b term, so it's not a trinomial anymore. It is a binomial, so it has two terms, and your a and c value must be perfect square values. So for example, 4 is like 1 is an example because 1 times 1 is 1. 4 is 2 times 2 is 4. That's a perfect square. Like, and so on. So like 3 times 3 is 9. 4 times 4 is 16. Those are all, so 1, 4, 9, 16, those are all perfect square values. So in this case, anytime you see a binomial with two perfect squares, you're going to take the square root of the first term and the square root of the second term. So when I take the square root, I make my two binomials, and I would end up having the square root of 81 is 9 times 9, or just 9, so it would be 9 and 9. The square root of x, so you have two x's, and you're going to make it 9x and 9x. So that's my first term. That comes from the 81, or your a term, 81x squared. Then I have the square root of 36 is 6. So I'm going to make, because it's a negative 36, I'm going to make one positive, so it's going to be 6, and one negative. So if I were to factor this out, I'm going to show you how it ends up being, or how you can check your answer to see if you're right. If I FOIL, I do 9x times 9x, which is 81x squared. Then I have 9x, my outside, times negative 6, which is negative 54x. 6 times 9 is positive 54x. And then I have 6 times negative 6, which gives me that negative 36. These terms would cancel, and so I get my original, so I have 81x squared minus 36. So this would be my final answer, but I was just showing you how you could check it. Now, example 2, I have b squared minus 144. So I would take the square root of b squared and the square root of 144. So I would have b and b in the front. So if you think about it, b times b gives me b squared. And then I have 144, which the square root of 144 is 12. So I have a plus 12 and a minus 12. If I did 12 times negative 12, I would get that negative 144. So that would be my final answer. Now this one, you always have to go back to the question, can I factor out a GCF? And in this case, I can. And it's going to be 2. So I have a 2 on the outside. I have 2 times what is going to give me 2x squared. That's going to be x squared. 2 times what is going to give me negative 32. That would be negative 16. So I would be left with, I would have 2 times x squared minus 16. Now, I would actually have to factor this more because I see that I have a perfect square value here, which is that 1. And I have a perfect square value of 16, and it's the difference, so I know that I can factor this more. So I would have 2 times, and I would have x and x, because if you think about x times x gives me x squared. And then to get negative 16, I would have to have a negative 4 and a positive 4. And that would be my final answer. Because I won't be able to factor anymore. Now with this one, I have 2m to the third, and then this one, actually, I'm going to include another m on this one. So I have 2m to the third minus 50m. In this case, I want to see if I can factor out a GCF, and I can because I can take a 2 out, but I also can actually take 1m out. So I'm going to first, I can take out a 2, so I'd be left with m to the third minus 25m. But I know I can also take out an n from both of them. So I'd have m to the second minus 25. So I would have my GCF of 2m times m squared minus 25. I now want to see if I can factor more, and I see that I have two perfect square values, and there's this difference. So now I can take the square root of both of those terms. So I have 2m times m and m, because m times m is m squared. And then I have a minus 5 and a plus 5, which is going to give me that negative 25.